asthmatic patients and how corticosteroids actually block anti-IgE activities. So I'm going to talk a little bit about the researcher's definition of asthma. So asthma is a chronic inflammatory disease involving chronic lung inflammation and narrowing of the small airways through the combination of excess mucus production and smooth muscle contraction. So asthma is an atopic disease which is the development of an allergic hypersensitivity, and some examples of atopic diseases are eczema, hay fever, and various food allergies. So what is asthma? So this is kind of more of my definition. So asthma is a long-term inflammatory disease, which is due to the remodeling of the airway, as we can see over here, an asthmatic bronchial muscle opposed to a normal bronchial muscle. And this is due to the cell proliferation, adding cell layers to this bronchial muscle, as you can see, almost contracting the airflow. Also, we see collection of mucus inside. This also decreases the airflow. And inflammation of the bronchial muscle, so that just this red inner lining. So basically, what asthma is it's just the decrease of airflow as opposed to the normal person. So what causes the development of asthma? So first we have our environmental exposures, you know, your pollens, your ragweeds, just anything that you can ingest or inhale. Also genetic, it can be passed down through genomes. I'm a great example of that. I was born with asthma because my parents had it. And there's other patterns such as maternal smoking before and after pregnancies, also early uses of antibiotics, as well as presence of cockroaches within homes, so kill those pests. And basically the development of asthma alters your immune response, leaving you more susceptible to having an asthma attack when presented certain antigens or allergens. So what causes an asthma attack? So when growing up, I learned about these things called triggers. And these triggers consist of allergens, again, you know, particles in the air, pollen, ragweed, dust mites, animal dander, and then also exposures to chemical fumes, such as high exposures of chlorine and ammonia, have also been linked to causing asthma attacks. And air pollution, it can either be manufactured or natural. And this is kind of the odd one out, but workplace exposures. Latex has also been connected to cause allergic reactions or asthma attacks. So just working day-to-day basis with your latex gloves could ultimately cause an asthma attack. And then finally, obesity and lack of exercise. So a little bit of background information on allergic reactions. So we're going to first start off talking about antigens. So antigen is any substance usually foreign to the body that binds specifically to an antibody. And the antibody we're going to be talking about right now is IgE, or immunoglobulin E antibodies. And they will be represented through this blue triangle. And so these IgE antibodies are proteins consisting of two heavy and light chains that facilitate the clearance of this antigen. And now we have our B cells. Our B cell expresses membrane-bound antibodies after interacting with these antigens. So basically, B cell has these antibodies that are produced to take care of antigens that are presented into the body. So continuing a little bit about the background information, we're going to start with mast cells, and it's a cell that is present in various tissues which have receptors to the IgE, immunoglobulin E receptors, and then undergoes IgE-mediated degranulation. And what I mean by IgE-mediated degranulation is the leakage of histamine. So these pro-inflammatory mediators, or histamine, are chemicals released from the mast cell that tend to cause inflammation, leading to the allergic reaction or asthmatic symptoms. So a little bit about B cell description. So you have your B cell. Your B cell produces these IgE antibodies, and what's crazy about people who have asthma, they produce more antibodies than a normal person would. This leaves us more susceptible to having an asthmatic symptoms such as coughing and wheezing. So how does an asthma attack really work? So an antigen binds to the specific antibody on the B cell. This then facilitates an antibody class switching, which basically just means that those antibodies switch over and attach to the mast cell. So then the second exposure of that same antigen causes the leakage of the histamines, or these pro-inflammatory chemicals, to create inflammation within the airways and constricting airflow. So this is the process that happens before the first exposure of the antigen. So your antigen is then presented through an APC or dendritic cell, basically an antigen presenting cell, which talks to this naive T cell. It then drives the naive T cell to become a Th2 helper cell, which then tells the B cell to produce IgEs to facilitate the clearance of these antigens, creating multiple B cells with the same antigens called memory B cells, which then facilitate in antibody production and also antibody class switching. So with asthmatic patients, their Th2 helper cells tell the B cell to replicate and duplicate more B cells to facilitate the clearance of that antigen and more plasma cells, causing the production of IgE to increase, as well as the number of antibodies that are going to be facilitated within the antibody class switching. So resolving allergic reactions. So your immune system learns to turn off almost, and what I mean by that is your regulatory T cells go and calm down your immune response. This is through the release of anti-inflammatory mediators, including interleukin-10 and resolvins, and we're going to be touching on resolvins today. So resolvins, or SPMs. Resolvins are classified as metabolites or specialized pro-resolving mediators. Good example of these are molecules that can be derived from omega-3 fatty acids. And basically what they do is they coordinate functional responses to nearby cells, just ultimately just telling nearby tissue cells and sending out anti-inflammatory signals to those tissue cells. This development of resolvins helps resolve chronic inflammatory diseases such as asthma through the depletion of B cell IgE production. So I'm just going to be talking about two different treatments for asthma, one being long-term control medicines as well as quick relief. So you have your inhaled corticosteroid, and basically that's just your day-to-day inhaler, helping your bronchial muscles relax from day to day, and that's up here at the very top. You also have your nebulizer, which smooths the bronchial muscles of constriction of airflow through the injection, well not injection, through the intake of aerosol, and that is right here. Now I really haven't had a lot of experiences with prevention shots, but there have been a lot of cases where you can take active measure in getting these prevention shots to deplete your IgE production within your B cells. And then quick relief medicines, I think we all know the rescue inhaler, or albuterol. So how do rescue inhalers really work? I'm going to kind of run through it really quick and then give you a visual example. So first they activate G proteins, which then activates the effector of the adenylate cyclase. Through the conversion of ATP, creates this AMP cyclic pathway. So basically, it does relax your bronchial muscles, but it actually increases inflammation. So here's the visual. So you have your rescue inhaler bind to this receptor of the cytoplasm, then activating your G protein, and this effector, the adenylate cyclase, once converted through ATP, creates a cyclic AMP, ultimately activating protein kinases and helping your bronchial muscles decontract. So we're going to kind of be talking about the hormones or different hormones that you could be taking. So corticosteroids. Corticosteroids are classified as steroidal hormones. The physiological processes consist of immune and stress response, basically killing active immune cells but not memory cells, and doesn't actually treat the underlying disease itself. Corticosteroids can be taken orally, applied to the skin, or inhaled. And we'll be kind of talking about how corticosteroids are inhaled. So, but before I get into that, a little bit of history of corticosteroids. The first uses of corticosteroids was in 1944 Olympics, when the Soviet Union had given corticosteroids to their runners in order for them to run longer distances. And Richstein, Kendall, and Hensch all won the Nobel Prize in 1950 for the application and treatment of rheumatoid arthritis, basically killing those immune cells. But what we know now is that they killed off immune cells but not those memory cells, so the symptoms of arthritis could actually come back. But at this time, it was deemed the miracle cure, basically stating that if you had a problem, if your hand wasn't fully functional, if you were breathing or wheezing, you could take a corticosteroid and instantly become better. So it was kind of a miracle, so they just deemed it the miracle cure. So this is the paper I'll be talking about today. And corticosteroids inhibits anti-IgE activities of specialized pro-resolving mediators on B cells for asthmatic patients. This was done at the Department of Microbiology and Immunology at the University of Rochester in Rochester, New York. So the methods that they had done were enzyme-linked immunosorbent assays, or ELISAs, and this really determines the presence of antigens and antibodies. They had also done a cell proliferation assay, which determines production of B cells through radioactivity. So the evaluations that they were trying to make, they wanted to determine what these receptor mediators of specifically 17-HDHA and RBD1, those are our SPMs, or our resolvins, and how they really affected IgE production within B cells. They also wanted to evaluate how these SPMs block spontaneous B cell production to reduce inflammation. So talking a little bit about the ELISA method, again, it determines the presence of an antigen or an antibody. So first you have your capture antibody. Your capture antibody is then bound to a targeted antigen, which then is bound to a conjugate antibody with an enzyme attached. So once the substrate acts on that enzyme, creates fluorescence. So we're able to determine the presence of an antigen or an antibody through the intensity of light. And then now talking about the cell proliferation assay method. So again, this determines the production of B cell production through radioactivity. So your B cell is stimulated, then given a radioactive nucleotide. This then causes the B cell, the radioactive B cell, to duplicate and replicate. And through the measurement of radioactivity, we can determine the number of B cells that were replicated. So explaining the evaluations a little bit, kind of coming back to this slide early in the presentation. So once this antigen binds to these antibodies, these IgE antibodies, they wanted to see if these SBMs could deplete the number of antibodies that were going to be bound to this mast cell, or to completely get rid of it at all. This would then hold the histamine within the mast cell, not releasing the pro-inflammatory chemicals, thus not causing the collection of mucus, remodeling of the airways, and inflammation of the bronchial muscles, and overall just not decreasing the amount of airflow. So SBMs can reduce the effects of IgE. And so this is our ELISA graph, and as we can see on the bottom, on our x-axis, we have the number of resolvins, or concentration of resolvins, and then on our y-axis we see the production of IgEs. And what they had come to find is that there is a relative decrease with the IgE production when you increase your resolvins. And the significance of their significance, basically meaning that this line states that from no treatment to full treatment, there is a full significance. And we can see from no treatment to partial treatment, there is some significance, as well as none to full. And again, the symbols, like the square, are representing of one person, just so you guys don't get confused about that, because I know it's kind of confusing. Oh, so then SBMs can reduce the effect of IgE production. So that was the conclusion. So now we're looking if corticosteroids can block block inhibitory effects of these SBMs. Excuse me. So again, we have a similar graph, but instead of just having our resolvins on our x-axis, we also have DEX, which is our corticosteroid. So again, we see a relative decrease when we increase resolvins, but after 24 hours and being treated with a corticosteroid, we see a relative increase in IgE production. So now we can determine that corticosteroids significantly block inhibitory effects of these SPMs due to the increase of IgE production. And again, we see significance in this graph through no treatment to full treatment, as well as no treatment of corticosteroids to full treatment. So the problems with corticosteroid treatments, it inhibits suppressing activities of IgE class switching, which leads to the failure to resolve chronic inflammation. With this also being a problem, it interferes with the ability to respond to those resolving mediators, or those SPMs, through the enhancement of B-cell IgE production, as well as preventing those IgE anti-activities of those SPMs, or those resolvins. So alternative treatments to corticosteroids, treatments such as derived from omega-3 fatty acids, these treatments promote the resolution of inflammation and narrowing of the airways, basically what a corticosteroid does, but what it doesn't do is it doesn't decrease IgE production within B cells while ensuring ensuring homeostasis within the cellular tissue. So basically, omega-3 treatments do exactly what corticosteroids do, but help the underlying factors of this disease. So a great example of omega-3 fatty acid treatments is taking your fish oils every day. It's very simple, it's very easy. It could act as a corticosteroid, but actually help you deal with the underlying disease. So summary and comparing these two treatments. So we have our corticosteroids and our omega-3 treatments. Yes, we do see that it suppresses instant inflammation, but we also know corticosteroids do not treat the underlying disease. This leads asthmatic patients to become more susceptible to receiving irritation and inflammation later down the road. And with omega-3 treatments, we see that it regulates that IgE production, creating homeostasis within the tissue, ultimately promoting the destruction of the inflammatory disease that corticosteroids does not do. So if you have asthma, one thing I can tell you right now is just take your fish oils and stop taking Pulmicort. That's my references. Shout out to Allison. She helped me with some of these slides while Dave was gone. So, but the man helped me out a lot, and I really do appreciate it, and all the time you guys have given me throughout these years. So, thank you guys very much.
The omega-3 fatty, whatever, does that give like instant relief, or is that just more long-term?
I think it could be more long-term, and just the development of accepting those resolvins over time could help your depletion of those IgE productions, leaving you less susceptible to having asthmatic symptoms later down the road. Jackson?
I know I asked you this question earlier, but I want to ask it with everybody here. I know that some treatments of multiple sclerosis have immunosuppressant drugs, which are corticosteroids. Do you think this could be an also alternative treatment for other chronic inflammatory diseases, not just asthma, so like rheumatoid arthritis and multiple sclerosis?
I had not done any research, but if they have to do with just basically the IgE production and the clearance of that antigen, then I would guess yes. But that's just an educated guess. Allison.
So you said earlier that the so asthmatics just automatically have higher levels of IgE. So if they were to take fish oils, does that mean that their levels would be then more normal, or would they still be at an elevated rate with the reduction of added fish oils, just making them on par with the non-asthmatic responses?
I think it wouldn't bring it to normal levels, because with an asthmatic patient, your airways are always going to be constricted through cell proliferation due to the layers of cells that have been added. So I think it's just depleting the number or the production of those antibodies, but not bringing them back to normal.
Okay. And then I had another question. Can you imagine one of the plots? I think this was the one with the DEX added part. Cool. So looking at the numbers on the side, so I'm looking at the right-hand side, you've got a reduction from, so relative increase. So you're going from about the 35, 40 nanograms per mil up to about 45-ish. Is that enough of an increase compared to the decrease? You're going down to about 25, so that's only a difference of about 15 nanograms per milliliter. Is that enough of an increase of the, whatever the hell this is, the IgE things, to cause now a different type of immunoresponse? And what what would be the minimum amount of difference that you'd have to see a different immune response?
No, yeah, I understand what you're trying to say. I'm trying to think of. I don't know specifically a noticeable decrease in IgE production, what that specific number is. I do believe that this, again, this kind of ties back into your last question. I don't think that it will bring IgE production back to normal, but it does deplete in some ways. And by doing something as simple as taking your fish oils, even though there isn't this huge jump or noticeable jump, it actually, statistically shows that your IgE production does
But doing
decrease.
just enough to make that one less thing causing trouble.
Just enough.
Cool.
I have a question on this plot too. So why are there so many more
Then the
data
last one,
points
yeah.
for the 17 HDHA versus the RBD1? Am I reading that right?
Many of these patients that had data ran on them, a lot of them actually saw no changes at all, because this also ties back into Allison's question, that this is very, very, very minimal treatment to treat this, these IgE productions. So a lot of these data points and the fluctuation of these data points, especially from the last slide as well, was just due to the insignificance that it had, and it just didn't have really any change.
All right, let's clap them out.